Welcome to Study Loop.
So whenever we're doing like a related rate problem, the best thing to do is just go ahead and plug in, or at least try to draw a picture, and then plug in everything you have. So we have this triangle here with one side length 12, 15, and the angle between them is increasing by a rate of 2 degrees per minute. And then over here we have like our third side. So I'll just go ahead and call this third side C. And actually, before we do anything, whenever we are working with like calculus, we should convert everything from degrees to radians, because a lot of times things will not work out if we do them in degrees. So I'm just going to come over here and convert this to radians first before we go any further. So remember, to do that, we would multiply by pi and divide by 180. So it would be 2 over 180 times pi, and then that would just be pi over 90. So we have pi over 90 minutes. So that will be our units for this, or I guess rads per minute will be it. Radians per minute. And so this is very important for us to do, though. So just kind of keep that in mind. And then over here, I guess I should also convert this to pi third as well. So this is pi third. Okay. Now, let's see if we can find some way to relate all of these things. So we want to know about this third side. We have two side lengths of the triangle, um, and we have this angle here. Well, we can actually use the law of cosines to relate everything here. So this is going to be c squared is equal to, and I'll call this a and b. And the reason why I'm using c is because we know the angle across from this. All right, so it'd be c squared is equal to a squared plus b squared minus 2ab, and then cosine of the angle across from that, which in this case is going to be theta. And now, since sides A and B are supposed to always be constants, we could just go ahead and plug those in to this. So we would have 12 squared, which is 144. So we have c squared is equal to 144. And then b squared, so that would be 15 squared, so 225. And then 2 times 12 times 15 is 360. Okay, and since theta and c are going to be changing, we don't want to plug anything in for those, at least quite yet. But let's go ahead and kind of simplify this down a little bit. So 144 plus 225 is 369. So this would be c squared is equal to 369 minus 360 cosine theta. Okay, so now we have this relationship between this angle theta and our side C. Now, over here, they want us to find how is the third side increasing at this angle. So since we're trying to figure out how fast this is increasing, so this is going to be dc by dt, so we want to find the derivative of c with respect to time. And then over here, or actually I should say this here, is actually telling us how theta is changing with respect to time. So we have d theta by dt. And at this point, if we just come down here and take the derivative of this, we can go ahead and implicitly differentiate each side. And that should give us, so on the left we would have 2c times, and then we use chain rule, so the derivative of c with respect to time is just going to be dc by dt. 369, that's just a constant, so that goes away. And then the derivative of cosine is negative sine, so that would be 360 sine theta, but then we have to implicitly differentiate again, since theta and time are not the same variable, so it'd be d theta by dt. Okay. And now at this point, we can actually just start plugging stuff in, and then we'll see what we need after that. because we've already implicitly differentiated, or just took the derivative on each side. And so we're interested when theta was 60 degrees, or pi third, and we were told that our change of theta is going to be a constant pi over 90. So let's just go ahead and plug those in over here. So actually, I'll divide each side by 2 first, so that would just give us 180 here. And so we don't know what c is yet. We don't know what dc by dt is. That's what we're looking for. Then we'll have 180 times, so sine of pi, or sine of pi third, which is going to be root 3 over 2. And then d theta by dt is supposed to be pi over 90. Okay. So actually 90 and 180, these would simplify down to 2, and then actually those 2's cancel out with each other. So if we were to rearrange everything now, I'll divide over by c, so we get that our change of c with respect to time is going to be just root 3 over, or root 3 times pi over c. So we need to go ahead and figure out what is c going to be. And then from there, we can go ahead and get an estimation for this. So we know our relationship between c, or at least how to find c, is given by this equation right here. And so again, remember, we're interested in when theta is equal to pi third. And so at that point, pi third, or cosine, is going to be 1/2. So that would be 369 minus 180. So 369 minus 180 is 189. And then we just take the square root on each side. So we get c is root 189. So then we can come over here and plug that in. All right, so this would be root 3 pi over root 189. And the units with this should be, so the units for our side were in meters, and then time were in minutes. So this would be meters per minute, and then actually let's just go ahead and plug all these in and see what we get. So we can get like an estimation of it. So root 3 times pi, and then all over root 189. And this is going to give us something around 0. I lost it. 0.395 meters per minute. So if you want the exact answer, it's up there, and if you want this approximate answer, it's there. But again, remember, something that's really important when we did this was when we're doing calculus stuff, any kind of degree, you always convert it to radians, unless they for some reason tell you not to. Because the entire way we have like these derivatives set up, it's always in terms of radians for like sine, cosine, and all of that. So yeah, just kind of keep in mind we always use radians, because otherwise, at this point, we would have just got a completely different answer.